It's okay. It's okay. Cool. What's your name again? Yeah.
The person that monitors that is Tiffany.
Tiffany. Cool.
She monitors that box.
Cool. I'll give her. Thank you. What's going on, guys? Welcome to Amigos Code. My name is Nelson, and in this course I'm going to teach you everything you need to know about functional programming with Java. So when I first saw functional programming, I was like, what is this? I saw functions, BiFunction, predicates being used all over the place, and to be honest, I only realized the power of it when I learned about declarative programming. So you see, most of us write imperative programming, which means that you define every single implementation detail of your code. Whereas declarative, you simply tell it what you want instead of defining, the details. For example, you might have a variable, or actually you might have a loop, right? So you define, the initial value, how to increment it, and how to stop it, right? So with declarative programming, you have none of that. You simply tell it what you want. And that's what I'm going to teach you in this course. So in this course, I'm going to teach you exactly, what the differences are between imperative and declarative programming, and why you want to move away from imperative programming. Then I'm going to teach you about the functional interfaces that Java has to provide. So functions, BiFunctions, predicates, consumers, suppliers, and all that good stuff, right? So once you learn that, you can then start to use streams and optionals to write code in a declarative way. And then towards the end, I'm going to teach you one of my favorite design patterns when it comes to functional programming, and that is the Combinator design pattern, which is really, really awesome. It's really good for validation, where you simply define all of your validations in an interface, and then you define exactly step by step what you want your validation to be. It's really, really awesome. And finally, I'm also going to teach you exactly about Lambdas, Callbacks, and the properties of functional programming, so that you fully grasp exactly the whole concept. So if you haven't subscribed to my YouTube channel, go ahead and subscribe, because that way I can, provide more awesome content like this. Without further ado, let's go ahead and learn everything you need to know about functional programming with Java. Alright, so before you start this course, I want to make sure that you really learn from this course, because I want to add value. So what I want from you is to go ahead and practice as I teach, because that's the best way for you to learn any new technology. Also, go ahead and join the private Facebook group. So if you have any questions, you can go ahead and engage with other students. And the group is full of cool people just like you. So this is all I wanted to say for now, and enough of me talking. Let's go ahead and learn about functional programming. Alright, let's go ahead and bootstrap our application, where I'm going to show you all the examples throughout this course. So I've got IntelliJ right here. And if you've never used IntelliJ, then I highly suggest you to enroll to my free course, where I teach you pretty much how to use this awesome IDE. And to be honest, as a software engineer, this is probably the IDE of your choice when it comes to Java backend development. So let me go back to IntelliJ, and the first thing I'm going to do is to create a project. And right here, I'm going to pick Maven. Now, the project SDK, it doesn't really matter whether you use Java 11, 12, or any other version, as long as it is above 1.7. So I'm going to stick with 11 right here. And as I said, the version does not matter. Next, let me go ahead and click next. And then right here for the group ID, I'm going to say com dot and then amigos, and then code. So right here, this could be your own organization. And right here, let me simply name this as Java and then functional. And then I'm going to press next. and then I'm going to save this under code and then Java functional, and then simply press finish. There we go. Let me actually collapse this Maven tab right here, and also let me collapse this, and right here go ahead and simply enable auto import to import dependencies. And this is the actual POM file, right? So if I open the functional, or actually Java functional folder, inside you see that we have only the POM file, and this contains the group ID, artifact ID, and then the actual version. So let me just remove that line and also remove this pop-up. And finally, I'm going to put this full screen. And this is all. And actually, let me just close this because we're not going to need this POM file. And this is pretty much everything you need in order to bootstrap the application to follow along. So obviously, I'm going to give you the source code at the end of this course, but I highly suggest you to practice as I teach, because that's the best way of you learning any new topic. This is all for now. If you have any questions about IntelliJ, as I said, go ahead and enroll to my course right here, where I teach you everything you should be aware of this awesome IDE. Let me go ahead and give you an example of imperative programming. So imperative programming involves you as a developer defining every single detail about your implementation. So right here inside of the source folder, inside of main and then Java, let's go ahead and create a new package. So you can right click on this folder, or I'm going to use keyboard shortcuts. And also you can see down here, so right here, you can see all the keyboard shortcuts that I'm going to use throughout this course. So right here, I'm going to use the arrow. So I'm going to select package. And then right here, I'm going to name this as imperative, and then OK. Now inside, go ahead and create a class, and this will be called as main. Now let me collapse this, and inside I'm going to type PS and then VM for public static main. There we go. And now we have a main method that we can run. So let's go ahead and define a list, and the type of this list will be of type and then person. So right here, let me go ahead and simply name this as people equals to, and then list, and then dot, and then of. So right here, what we're going to do is simply create few people, or actually few people of type person. So right here, let's go ahead and simply create a class. So let's go ahead and simply say static, and then class, and then person. And this person will have a name, so private, and then final string, and then name. And we also will define a gender, so enum, and this will be gender, and the gender will be male or female. And then right here, what we're going to do, or actually underneath, is simply say private final and then gender, and that will be the gender. And let me add this to constructor, and there we go. So now we have this class right here called person. And let me also define a toString method right here, so to and then string, and there we go. So now right here we can simply say list of, and then new, and then person. And right here, let's give it a name, so John, and John is a male. And let me have a static import for this, and let's go ahead and duplicate this. So I'm going to press Command D a couple of times, and there we go. So let's have Maria, and she's a female. Let's have Aisha, she's also a female, just like that. Let's have Alex, it's a male, and let's finally have Alice, just like that. and Alice, she's of course a female. So now that we have this list right here, let's go ahead and find out how many females that we have. So the way that we will do it with the imperative approach is, let me add a comment right here. So in an imperative approach is simply by doing the following. So first we need an empty list, and then of type, and then person, and then let me simply say females right here equals to list of, and then, or actually not even list of, let's go ahead and simply say new, and then array list. So this is an empty list. Now what we need to do is to loop through people. So let's go ahead and simply say for, and then person, and then person inside of people. And right here we're going to say if, and then person, or actually let me go ahead and simply say female, and then dot equals to person dot, and then gender, just like that. So if this is the case, I'm going to say females dot, and then add, and then person, just like that, and that with semicolon. And then right here at the very end, what I'm going to do is simply print each people. So again, let me simply copy this, just like that, and then right here, this, instead of people, this will be females, and this will also be female, and then south, just like that. So system.out.println, oops, just like that, and then female. Now if I go ahead and pretty much run this class right here, so let's go ahead and run this class, and there we go. So right here you can see that we have only females in our output. And basically this is pretty much what imperative programming is. So basically we are defining every single detail. So right here you can see that first we have an empty list, and then we loop through that, and then we have an if statement, and finally we have a final for loop looping through females. And you can see that there is a lot of logic, not a substantial amount of logic, but you can see that, for example, this if statement is some logic, and also you can see that this is a lot of code for something very simple. And this is what I wanted to show you about the imperative approach. Next, let's go ahead and implement this using the declarative approach, and you will see that it's much neater, and we pretty much just tell it what we want to do instead of defining every single implementation detail right here. So to use declarative approach with Java, i.e. functional style programming, we simply have to do the following. Let me collapse this. So right here, so what we're going to do here is, instead of us creating a list and then having two for loops, what I'm going to do is the following. First, let me go ahead and pretty much have a comment, and right here this will be declarative and then approach. Now the way that we use declarative approach is by using streams with collections. So don't worry about so much about what a stream is, because I'm going to show you exactly later on, but for now just follow along. So go ahead and simply say people. So people is the original list right here, so this list of people, and then dot, and then stream right here. So now we have a stream, and a stream allows us to go into an abstract mode where we simply tell it what we want. So right here, let's go ahead and simply say dot and then filter. And what we want to filter is basically this. So right here we have a person. So this takes a person. And then I'm going to say the exact same thing right here. So I'm going to take this if statement. Oops. Let me press Command W a couple of times, Command C, and then put it here. There you go. So you can see that I'm filtering, and then this takes a person, and then I'm using this same if statement. So basically female dot equals and then person dot gender, right? And then finally I'm going to say dot and then collect and then collectors and then to list, end that with semicolon. And right here what I'm going to do is put this on a new line, and the same with collect, just like that. And right here we can simply now go ahead and simply say dot and then for each, and then we can use system dot and then out and then column and then print line. So now let me actually add right here. So let me simply add this as a south. So I'm going to print this just like that. There we go. And let me do the same here. So I'm going to copy that and then paste that. Take this comment, put it here so you can see exactly in the console what I'm doing. So now you can see that this is much concise. And right here you can see that I'm not creating a list and then adding to that list and then doing the if statement, so on and so forth. So you can see that is very straightforward, and I'm just telling what I want. So from the people array list, or a list, basically this is a list, I'm going to stream. So I'm going to go into this abstract mode, then I'm going to filter all the females, and then I'm going to collect to a list, and finally I'm going to print everything. So technically I don't even need this collect to list because I'm simply printing out things. So let me simply run this for now so you can see exactly what's happening. There we go. So basically you can see that we have the exact same output, right? So if I put this full screen, you can see that we have the exact same output, but the declarative approach is much neater. So obviously if you were to have this into a list right here, so this is where collect comes into play, and then I can remove this line and this with semicolon, and then extract this to a variable, and then say females, and then 2, right? And you can see that now I've got a list right here, and I could again simply say females 2 dot and then for each system dot out column print line. So if I run again, you can see that this is the exact same output. So there we go. Now you should have a full understanding of the differences between declarative and imperative approach. So obviously I've just shown you the difference between both, but there are a few things that we need to understand in order to write code like this, right? So I'm going to teach you about functions, BiFunctions, predicates, BiPredicates, consumers, and all the good stuff that Java has to offer when it comes to functional programming. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Alright, let's go ahead in this section learn about the java.util.function package. So basically this package contains functional interfaces that provides target types for Lambda expressions and method references. So each functional interface has a single abstract method. Basically you can have one interface with multiple default methods, but you must have only one single abstract method to be considered as a functional interface. So basically you can see some examples right here. So the assignment the assignment context. So this is how you, for example, define a predicate. And this is how, for example, you use it within the actual, stream. So right here, you've seen that we can get stream from a list, right? So stream and then filter. And there's another example where you can do some casting. So this package right here contains a bunch of functional interfaces right here. You could see BiConsumer, BiFunction, binary operator, by predicate, Boolean supplier, consumer, and the list goes on. So they are pretty much identical apart from the type. So the ones that you will most likely be using are functions by functions, predicates by predicates, and consumers. And also there is a BiConsumer. But I'm gonna explain exactly how everything fits together, because once you learn those main ones, then the rest will be very simple. So right here, I want to show you that. So we have a predicate. So where is the predicate? So let me find the predicate. So right here, so a predicate. Let me quickly show you a predicate and show you that we actually have used, a predicate before. So a predicate represents a predicate. Basically, this predicate represents a predicate, a Boolean valued function of one argument. So let me go back to IntelliJ, and right here, remember where we had this declarative approach? So right here, so this filter. So basically, if I pretty much extract this into a variable, you can see that this is a predicate. And look at this. This predicate looks like this. So the predicate accepts a person and then returns true or false based off that person, i.e. whether the person is of type female, right? But what we've done right here, we simply inlined like that. That's why you don't see the predicate keyword. But indeed, this is a predicate, and a predicate looks like this. So don't worry about this if it doesn't make sense, but I'm going to try my best to explain you exactly how you go from, normal Java functions to the functional interface world. Join me in the next one. Alright, so I've gone ahead and created a new package right here called functional interface. And inside of this package, I'm going to go ahead and create a class. And first, I'm going to name this class as underscore and then function. And I'm going to explain why I'm saying underscore right here. But for now, go ahead and simply say underscore and underscore function, or you can name this anything other than function without underscore, right? So right here, what I'm going to do is simply say public static void main to have a main method. And right here, what I'm going to do is simply do the following. So let's go ahead and create a function. So static and then function. So this function will take a number, right? So take a number and then increment that number by 1. So let's go ahead and simply say int and then increment, and then this will take an integer number and then it will return number and then plus 1. So now if I go ahead and simply say increment and then 0 and then end that with semicolon, and if I pretty much extract this to a variable, and for now let's go ahead and simply sout this increment, and let me put this full screen. Let me run this now. Oops, I'm running the wrong one, so I need to run this function. There we go. So you can see that the result is 1. Very simple. So if I put 1 right here, this will be So what I want to show you is how we go from this. So this is what you are used to this right here. So let's go ahead and learn about the function interface. So where is the function? So this one right here. So this says that represents a function that accepts one argument and then produces a result. So this is pretty much what we have here, right? So this function that we have, so this is a normal function in Java. So this is what you are used to. So this takes an input and then returns one single output right here. And this is pretty much the equivalent right here. So represents a function that accepts one argument and produces a result. So the way that we convert this into a function right here is the following. So let's go ahead and simply say function. And if I actually delete this, so I want to show you something. So function, you can see that this function takes a t, right? So t and then r. So basically these are the data types of the input and the output. So let's go ahead right here and simply say that this will be of type integer. So the input is integer and the output is also an integer right here. So now let me go ahead and simply say increment and then function, or actually increment by and then one function right here. And then this will be equal to, right? Now this is where things become a bit tricky. So here equals to, and then this will be the actual number. And then right here, we pass a lambda, and then I'm going to say number, and then plus plus. There we go. And that with semicolon. So you can see that this and this are the exact same thing. So basically, this integer right here corresponds to the actual input. So this one right here, right? This data type. This integer corresponds to the return type. And then this number corresponds to the parameter to this function right here. And then I'm saying number plus plus. Or actually, let me simply make them the same. So number plus 1. And let me also rename this function to increment by and then 1. So you can see that this is pretty much the same, but now we are talking in functional style world. So now the way that we use this is as follows. So go ahead and simply say increment by 1. And the reason why we're not seeing this function is because we can actually put it inside of this method. So inside of this main method, we can paste that function there. Or if you want, this can also be static like that, right? So let me actually put this on a new line so you see exactly how it is. So right here, I can say increment by 1 function. And what I'm going to do is simply say dot and then apply. So the apply pretty much takes the actual argument. So let me go ahead and simply say 1. And then right here, I'm going to say increment and then 2. And I can change this data type to integer. And then simply say south and then increment 2. And then let me simply run this again. You can see that we have the exact same output. So this is how you use a function. So basically, it's the exact same thing as this function right here, but in a functional style way. So if you have any questions about this, go ahead and drop me a message. But I'm going to show you exactly how all of this fits together, right? Because now you might be asking, why should I use, this function right here instead of a normal regular function, right? And don't worry, by the end of this course, everything will be clarified. So there are a few methods that I want to teach you. So right here, if I pretty much say increment function, or actually increment by one function dot, you can see that we have apply, and then this method right here, and then. So I want to teach you what this method is, because you might use it later on. So let me simply remove that, and this is all for now. Join me in the next video. See ya. All right, let's say that you want to combine multiple functions together to achieve a desired state or a desired output. So let's say that you have this function right here, so increment by one function, but let's also create another function. Or actually, let me not copy and paste, but simply say static and then function. And this function will take an integer, and this function will also return an integer. And then I'm going to say multiply by, and then 10 right here. So this will take the number, number, and then this will be a lambda, just like that, and then number times, and then 10, just like that. So we have this function right here, and what we want to do is after incrementing, by 1 right here, we want to apply that other function immediately. So you could do something like this. So you could say int increment, or actually multiply, and then equals 2, and then multiply by 10. Let me actually rename this to function, just like that. And then right here, you could say equals 2 multiply by 10 function dot apply, and then increment, and then 2, right? So this is not quite right, because this is the name, so right there, and then remove that. And this should be multiply by 10. Let me grab that name there, paste it there, and there we go. So now if I do a salt and then multiply by 10 function, well, actually, I'm getting all confused right here. So this should be multiply. There we go. So this is the actual output. So now if I run this, you can see that we take 2 multiply by 10 is 20. So obviously this is, quite normal for us to do, but we can do something better. So what we can do is simply combine the two functions together. So right here, what I'm going to do is simply say increment by one function dot, and then multiply by 10 function. And right here, what I'm going to do is simply extract this to a variable. So this will give us yet another function. And let me simply say add by 1, and then multiply by 10. There we go. So if I put this on a new line, and you can see exactly what it's doing. So now let's go ahead and simply say add by 1 and multiply by 10, and then simply say apply. And you can see that you can keep on chaining these functions as you go along. But for now, let's simply chain two functions. So now I'm going to say apply, and the number that I want is 1, right? So this should give us the exact same result. So 1 plus 1, 2, 2 plus 10, you guessed it right, that will be 20. So obviously I need to put this around system.out.println, just like that. Run this again. And you can see that we have 20 right here. So if I change this to, let's change this number right here. So instead of 1, let's go ahead and change it to 4. 4 plus 1, 5 times 10, 50 right here. And this is pretty much how you chain functions together. So if you have any questions, go ahead and drop me a message. Next, let me go ahead and teach you about BiFunctions. Alright, so what a BiFunction is the same as a function, but instead of taking one input, it takes two inputs and produces one output. Hence BiFunction for two things, right? So right here we have this function right here. So this one, add by 1 and multiply by 10. So let's say that the first number that we give it is the one that it should increment, and then the second one is the one that it should multiply by. So right here, let me go ahead and define this as a normal function, so you can see exactly the equivalent. So increment and, or actually increment by 1 and multiply, just like that. So now right here we have a second argument. So int num to multiply by, just like that. And now I'm gonna wrap everything within parentheses and then say times and then num to multiply by. Now the way that we define the exact same thing but using a BiFunction is as follow. So let's go ahead and simply say bi and then function. So the first argument is the first input, which is the actual number that we want to add 1 by. So let me go ahead and simply say this is an integer. The second one is also an integer. And the third one is also an integer. So bear in mind that you can have different data types depending of your circumstances. So right here, let me simply say that this will have the same name, but BiFunction. So usually you wouldn't include the BiFunction for the name, but I'm just doing it so that you understand exactly and reason about these things. So right here, this now will take two things. So because it takes two arguments, we need to wrap this within parentheses. So this will be number to increment by 1 and then number to multiply and then by. And this will be now a lambda. And what we do is simply say number to increment by 1 plus and then 1, right? So this is the exact same thing that we did here. And then this will be within parentheses. And then finally times and then number to multiply by. And that with semicolon. And let me just put this on a new line yet again, so you see exactly everything. So I've got bigger font because I want you to see exactly properly, but you shouldn't indent things like this. But basically this right here is the exact same thing as this. So now let's go ahead and use it. So right here, remember, we had this function, so add by 1 and then multiply by 10. So let's go ahead and say this now is a BiFunction, and this was the function example. So let me actually add a comment. So takes one argument and produces one result. So now the BiFunction is almost the same, but it takes 2 arguments right here. So let's go ahead and use our function. So right here, so increment by 1 and then multiply. Let's go ahead and give it 4. And then let's multiply 4 by 100. So basically this will be 4 plus 1, 5. 5 times 100, 500. So let's go ahead and simply, I'm not going to even put this into a variable. I'm simply going to say south, and then just like that. So let me put like that, and there we go. So now if I run this, you can see that we have 500 right here. Now let me go ahead and use the BiFunction. So if I escape out of this, and let's actually have the same system right here. So system.println, and right here, let me simply use the actual function. And I think we have to have it as static. So this guy right here. So this has to be static. There we go. Now it should appear BiFunction, and this should be dot and then apply. And apply takes 4 and 100. Now if I run this, you can see that we have the exact same result. So this one right here is using normal Java function, and this one right here is using the BiFunction. Let me go ahead and show you the actual docs. You'll see that we have lots of bi. So let me search for bi. So you can see that we have a double BiFunction, to int BiFunction, to long BiFunction, and all of these BiFunctions are the exact same thing as the function, but they take 2 arguments, as you can see here, right? So the same with predicate. So it takes 2 arguments and returns true or false. So this is the difference between a function and a BiFunction. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. All right, next let's go ahead and learn about consumer. So a consumer, so let me search for consumer right here. So consumer. So a consumer represents an operation that accepts a single input argument and returns no result. So let me show you exactly first the non-functional way and then the functional way. So let's say that right here, again, let's have public static void main, and right here let's go ahead and define a static class and then customer, and then let's go ahead and simply say private final, and let me put this full screen. So private final and then string and then customer name, private final string customer phone number, just like that. So next, let me add that to a constructor. And now what I'm going to do is have a function right here. So let me go ahead and simply say static. And then right here, let's go ahead and say greet and then customer. So this will take a customer. And right here, let's go ahead and simply say south and then hello and then customer and then dot customer name. and then right here, plus, and then comma, thanks for registering, and then phone number, and then plus customer dot, and then customer phone number. So let me actually put this on a new line so you can see everything. So now let's go ahead and simply create a new customer. So new customer, this will be let's say that Maria, and then Maria phone number will be 99999, right? So let me go ahead and cut this and then simply say greet customer, pass new customer, just like that, and end up with semicolon, just like that. So now if I run this class, you can see that we have hello Maria, thanks for registering, phone number 9999. So the way that we achieve the same but using the functional interface, so the consumer functional interface, is by doing the following. So let me go ahead and simply say static and then consumer. So consumer takes one argument, so this will be of type customer, and then right here let me go ahead and simply say greet customer consumer equals to, and then we'll take the customer, and what we're going to do is pretty much the exact same thing right here. So let me grab all of this and then paste it there, and basically now I can go ahead and simply say greet customer consumer dot, and then right here instead of apply we simply accept. Now let me go ahead and extract this customer, so Maria, and then also pass Maria right here. So there we go. So this is using functional interface. So this is actually consumer and then normal Java function, right? So if I run this, you can see that we have the exact same thing, right? So basically a consumer takes one argument and pretty much returns nothing. It's like a void function, right? So this customer right here is the data type of the input, so is this one. This customer is the actual name of the input, so this customer right here. And void, you could technically say that void is a consumer. So if you have any questions on this, go ahead and drop me a message. Otherwise, let's learn about BiConsumers. Alright, so let's go ahead and learn about the BiConsumer. So the same way that we've done with functions and BiFunctions, we have the same for consumer. So pretty much every one of these functional interfaces, they have the Bi version. So in front of it, they have the Bi version. So the Bi simply means that instead of taking one argument, it takes two arguments. Now let's go ahead and change this function. So let me simply grab that and let's go ahead and simply say v2, for example. So this will be the version 2. So what we're going to have is a BiConsumer right here, and let me import this. So first we will take the customer, and then we will have the boolean. So right here, so this boolean. So this boolean will represent whether we should hide the customer's phone number. Show, and then phone, and then number. So now we have an error because we have two arguments, and because we have two arguments, we need to enclose these within parentheses, just like that. Now right here, what I'm going to do is, instead of printing the actual phone number like that, I'm going to say the following. So I'm going to put this within parentheses, just like that. And right here, I'm going to say show phone number. So if show phone number, then we can pretty much print that. Otherwise, I'm simply going to have some stars, just like that. So now let's go ahead and test this out. So let's go ahead and simply say greet customer v2, and let's pass Maria. And then right here, let's simply say true for now. So this is actually complaining because we need to say dot accept. And if I run this, you can see that this is the version 2 of our function. Now let's go ahead and simply say false. Run that. And you can see that now we are hiding the number right here. So basically, if you were to convert this into a normal regular Java function, this would be as follow. So let me just duplicate all of this, just like that. Call this v2, and then right here we simply take the exact same variable, so show phone number, but right here boolean show phone number, and let me grab everything from here and then put it here. There we go. And that with semicolon, and I can simply now go ahead and say get, oh actually greet customer v2, pass Maria, and then true, run. There we go. And you can see that we have the exact same information. So there we go. This is how you use a BiConsumer. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. All right, let's go ahead and learn about predicates. So I've gone ahead inside of the functional interface package, created this underscore predicate class. And inside, let's go ahead and simply type public static void main. And let's go ahead and learn about predicates. So let's say that you want to do the following. So let's say that you have a function, so a normal Java function, so static, and then this will return a boolean. And right here, let's simply go ahead and say is phone number valid. So let's go ahead and simply take a phone number, so string and then phone number. And for now, let's go ahead and keep it very simple, but this validation is not real, but it's just to illustrate the actual example and purpose of predicates. So right here, let's simply say that this phone number, in order to be valid, it has to meet the following criteria. So let's return phone number dot and then starts with, and let's say that the phone number has to start with 07. And let's also say that the phone number and phone number dot and then length is equal to 11. So this is a simple phone validation method, but this is not real. It's just to illustrate the purpose. Now let's go ahead and simply do a south here, and let's go ahead and have this phone number. So 07 and then 000000000, and let's have another one 0 and then 9, and then we can add a couple digits like so, right? So the validation is not real, but this will illustrate the purpose. So now if I run this, so let me run this main method, you can see that I'm printing the number, but what I meant to do was to actually let me cut this. So what I meant to print was is phone number valid, and then pass the actual phone number. So the same with that one. cut it, is phone number valid, and then paste it. Run it again. You can see that the first phone number is valid, so it meets the actual criteria. Let's also have another one, so the same, but this will be 10 characters long. And if I run this again, you can see that the first one is valid, the second one isn't, and the third one isn't as well. So right here, we're simply doing a simple phone validation check. Now, in order for us to use the functional style, we can use the predicate. So predicate right here, so you can see, represents a Boolean valid function of one argument, right? So right here, the way that we use a predicate is as follows. So this exact same function as predicate will be something like this: static, and then right here, predicate. And then this will take a string. So this will be the phone number. And then let's copy this exact same name. And then let's simply say predicate. And right here, this will be equal to, and then phone number. So let's actually grab this. And then this lambda. And on a new line, I'm simply going to grab this. And then paste it. And then end with semicolon. Now let's go ahead and use it. So to use it is phone number valid predicate dot and then test. So this is the actual method that we need to use. So now we're going to test the following. Let's test the first number. So we know that the first number is valid. So basically this will be the exact same thing. So we need to simply sort this just like that. There we go. And let me duplicate this. And basically we should have the exact same output. There we go. And then paste that in. Let me do sort without predicate. And then right here with predicate. And if I run this, you can see that we have the exact same result. So true, false, false, and without predicate, true, false, false. So basically this is the equivalent. So the predicate is the equivalent as this normal Java function. And the cool thing about predicates is that you can have a bunch of predicates and then combine them together. So the same way that we've done with function using and then, we can also use it with predicates. So let's say that we have another predicate. So let's have another predicate. So static and then predicate. And this predicate will take a string and then let's say contains and then number. And then let's simply say number 3. So if the phone number contains number 3, so phone number, and right here I'm simply going to say phone number dot and then contains and then 3, just like that. Now the way that you chain predicates is as follow. So right here, let's simply go ahead and say is phone number valid. So we're going to pass this phone number. So this one right here. There we go. And then we can say dot and then is phone number valid predicate dot and then and another predicate. So the other predicate is contains number 3 dot and then test. Let's actually pass this number right here. So the last one. There we go. And let's wrap everything without a system.print line. Let me put this on a new line. And just like this. There we go. So if I say right here, is phone number valid and contains number 3. equals, and then plus the actual result. Let's do the same for a different number. So let's actually do for this one, very first one. So right here, and let's actually put a 3 right here. So this should be false because the phone number isn't valid, but it contains number 3 right here. But this one, the phone number is valid, so it starts with 07, 11 characters long, and contains number 3 at the end. So let's go ahead and run this method, and there we go. So you can see that the second one is true, as I explained why, and the first one is false. Now you can use AND, but you can also use OR. So OR means either one of them is true. So if I was to say right here, so instead of AND, I can use OR, right? And then if I remove 3 here and put a 0, run this, this will still be true. It's true because we only need one condition to be true. If you use an AND, so if you chain multiple predicates together using an AND, all of them have to be true. So the same way that we have predicates, we have by predicates, by and then predicates right here. And basically they are the same thing, but instead of taking one argument, they take 2 arguments. So I'm not going to give you a full example on by predicates because you should be familiar now with by predicates, by functions, by consumers, so on and so forth. So if you have any questions on predicates, go ahead and drop me a message. Otherwise, let's go ahead and learn about the final functional interface I want to show you, and then we can start putting all the puzzle together so that all of this starts to make sense and how you actually end up using it. Join me in the next one. See ya. All right, go ahead and inside of the functional interface package, create a class called _supplier with a public static void main method. So let's go ahead and learn about what a supplier is. So if I go to the docs right here, you can see that they say supplier T represents a supplier of results. So basically, sometimes you might have a method right here that simply, let's say that we have a method like that. So like a method like this. So static and then get, or actually string, get connection URL. Or actually, let's simply say get DB connection URL, right? So this will take no arguments, and let's simply return. And then, for example, JDBC column / / localhost, and then 5432 / let's say users, right? So this is not real, but you get the idea. So the way that we can use this function now is if I simply say south and then get DB connection URL, and then if I run this, you can see that we get the actual connection URL for some kind of database. So the purpose of this function right here is simply to return a value right here. So this is the value that it returns. So we can use a supplier to represent the exact same thing. So I'm going to copy this URL, and to have this Java function as functional, we simply have to say supplier, or actually static, and then supplier, and then this will supply a string, and then get, let's grab this, and then supplier, and right here equals to, and then what we need to do is simply have parentheses, and then we simply pass, or actually return this, just like that. So if I put this on a new line, so you can see exactly what I'm doing, and you can see that now this is the exact same thing. But if I go ahead and simply say system.out.println, so south, and then right here to use this, I can say get db connection URL supplier dot and then get. So now if I run this, I do get the exact same result. So this is pretty much how you use a supplier. So a supplier simply returns any kind of value that you want, right? So this data type doesn't have to be a string. It could be, you know, your custom classes, your custom objects, you know, an array, pretty much anything that you want. So if, for example, if you wanted to return a list right here, you could simply say list and then of type and then string right here. And then here I would say list dot of, and then just like that, and that would semicolon, right? So now if I run this, you can see that this now is a list. So if I was to return something else, so right here, let me simply add comma, new line, indent this like so, so it's much neater, just like that. Oops, just like that. And right here, let's simply say customer, for example, right? So get connection URLs and then supplier, and then here URLs, run this, and there we go. So now we are returning a list with 2 URLs. So if you have any questions on suppliers, go ahead and drop me a message. Otherwise, let's move on. Alright, so by now you should see exactly the differences between writing a normal Java function and functional interfaces. So the benefit of, you know, knowing the functional interfaces is when you start to use optionals and streams, but more specific streams, right? So once you start using streams with all of these functional interfaces, you will start to write clean code. And that's what I'm going to teach you next. Okie dokie. Now that you've learned about consumers, functions, BiFunctions, predicates, BiPredicates, and suppliers, and also I think BiConsumers, now let's go ahead and actually learn how this is useful to us when writing code. So go ahead and create a new package under Java, so package, and call this as streams. Now go ahead and create a new class and simply call it underscore and then stream, just like that. Enter, public static void main, enter. Now remember, inside of the imperative package, go ahead and open that up, and let's actually steal some code. So right here, let's steal all of this, so the enum gender as well as the person class. So let me close this, and then right here let me paste that in, and I'm going to cancel because I don't want to import from imperative.main, so cancel. And let me go back again, and let's actually steal some code again. So let's take this list right here. So we're going to take this list, and then we can close this once more. And then right here inside, let's go ahead and paste it. And you see right here, it's trying to import from imperative.main. Cancel out of it, and let's simply import the actual list ourselves. So I've just pressed option enter, and right here let's import male and gender, just like that. And finally, let's go ahead and add a static import for those. So I'm just pressing option and then enter, add static import. Now let me go ahead and close this, and let's actually use what we've learned in the previous section with streams. So this is pretty much where everything starts to make sense. So let's go ahead and use a couple of those functional interfaces that we've learned. So if I collapse this, or actually open this, so consumer, function, predicate, and suppliers. So go ahead and simply say people dot and then stream, right? So stream pretty much takes us to an abstraction mode. And if you want to learn about all of this, I've got this course right here where I teach everything about the Java Streams API. Because once you learn this, the way that you write your Java code will change quite significantly. So stuff that you used to take 20 lines of code, you can simply collapse it into perhaps 5 lines of code. And to be honest, knowing how to use the Java Streams API will make you a much better developer. So I also have a free video on YouTube where I teach about filter, sort, group by, all match. Basically, this is an introduction of this awesome API. But for now, let's go ahead and learn some of these methods. So go ahead and say people.stream, and now go ahead and simply say dot. So what I want you to do is to actually look carefully. So right here, so look at the methods that we have. We have map, collect, filter, find first, for each, all match. But what I want you to see is exactly, look, the map function takes a function, right? Takes a function of some type that extends person, and then you can see the other one, so the other argument, so question mark extends R, mapper. So this is exactly what we've learned, right? So a function takes an input and produces an output. So the same with collect. So collect is a supplier, and you can see a BiConsumer. So this is awesome, right? This is everything that we've learned. So the same with filter, takes a predicate, find first, so this returns simply an optional. For each takes a consumer, right? Let's look another one. So for example, drop while, this takes a predicate, find any, flat map, so this is a very useful function, takes a function inside, and right here, flat map to int, map to double, so this takes a to double function, right? And you can see right here, non-match, a very useful function as well. Reduce, binary operator, and then right here you have another reduce, and then look at this, sorted takes a comparator, it's not relevant to us. Take while, you can see that this takes a predicate and to array int function. Basically, this is pretty much everything that we have learned, right? So functions, BiFunction, consumers, predicates, and the other good stuff. So basically, this is now where everything comes into action. So let me go ahead and show you, for example, how to use this map function. So go ahead and simply select the map function, and the map function simply does transformations. So right here, this takes a person, right? And from here, what we want to return. So I want to return person dot and then the actual gender. Now let's go ahead and simply say dot and then collect, and then collect is to set, right? So, and also let me extract this to a variable, genders, and then south, and then genders, or actually not even south. So let me simply remove that, because I want you to see exactly what we're doing. So right here, so instead of collect, let's go ahead and simply say dot, and then look at this, for each takes a consumer, and we've learned about consumers, right? A consumer simply takes an argument and produces nothing, so void, right? So right here we will take a gender, and what we want to do with this gender, so we want to simply do a system dot out dot print line and then gender, and now we can use method reference with this like so, and beautiful code. Now let me go ahead and run this method. So you can see what we are doing. Ta-da! There we go, male and female, right? So you can see that we mapped everything. So right here, we stream the people list. So, oops. So right here, we stream the people list, right? Contains a bunch of people right here. So John, Maria, Aisha, Alex, and Alice. So we map, so we perform a transformation on that list. So we convert every single one of them into a gender. So now we simply have a list full of genders, and then we collect to a set, removing duplicates, and then we simply print. That's why you see that we have only male and female right here. So if I was to have another gender right here, cannot, or actually prefer not to say, but basically this is not gender, I'm just giving you an example. So right here, let's add another one, another person right here. There we go. And then prefer not to say, this will be Bob. And you could tell that this is a gender, but so if I run this, you can see that now we have prefer not to say as well right here. So if I was to now map this into the actual name, right? So let's say name and then run this. We simply now get the actual names instead of genders. So this is really, really, really awesome. So let me also show you that we can simply get the length of each name. So let's also perform another map operation, right? Or in this scenario, let's say map to int. This takes the actual name, so this time is name, and then simply say name dot and then length. And right here, we're not going to collect a set, so let me delete that. And then we can even change this to method reference, just like that. If I run this, you can see now the length of each name. So this is the power of streams. So you might be asking, what is this, right? Or what is this? Or what is this? So let me just show you right now. So what I'm going to do here is simply extract this to a variable and also this to a variable and also this to a variable. And now check this out. So this is what you've been learning in the past videos. So look at this function that takes a person, returns a string, and then the same here, toInt function. We haven't learned toInt function, but basically this is the same thing. So this takes a string and returns an integer. That's all it does. And you can see right here, int consumer. So an int consumer simply takes an integer and it prints out the result. So right here, so let me actually replace this with a lambda so you can see exactly what is this. You can see that this is what we've been learning throughout this course. But when you use it with streams, you don't have to have all of this syntax. Basically, you can ditch the left hand side and just keep these, right? So if I now inline everything, so Command Shift N, Command Shift N there, Command Shift N there, and look at this, right? And here even method reference. And there we go. So if you want to learn more about streams, go ahead and check my course on Java Streams API, where you learn everything about writing code in a declarative way. This is all for now. Join me in the next one. All right, let me show you some other methods right here. So still right here. So let's go ahead and for now, I'm going to pretty much just comment everything right here. So I'm going to comment this. And right here, let's go ahead and simply say people dot and then stream. And then right here, let's go ahead and simply say all and then match. Basically, we want to know that in our list we only have females. So right here, so this takes a predicate, and remember, a predicate looks like this. So this will take a person, and then in this list we want to make sure that we only have females. So female dot and then equals person dot and then, well, actually not people, person dot and then gender. There we go. And now end this with semicolon. And if I extract this to a variable, you can see that this is a boolean. Now let me go ahead and simply say contains only females. There we go. And if I do a south on this, south, and then contains only females. And let me actually go ahead and destructure all of this. So I'm going to extract this to a variable and check this out. So right here, so we've learned about predicates, right? So this is what we've learned previously. So now let me go ahead and run this again. And you can see that it's false, right? Because in our list, so right here in our list, we contain both male and females. So if you want, for example, to say, or say the opposite, you could say, for example, I think match. Let's look at match. So any match right here, right? So any match. So any match means any match taking our predicate. So if we have at least one female, then this will return true. Run this. There we go, true, right? So if I, for example, remove all the females here, just like that, run it again, and it's false now, right? So let me undo all of that. And finally, we have, I think it's non-match, right? So let's say that. Now we change this to prefer not say, and let's remove Bob from here. So basically, I want to make sure that in our list, we do not have someone with prefer not say gender. If I run this, you can see it's true. If I add Bob back, this will be false. There we go. So you can see the power of streams, right? So obviously we have other methods, really useful methods. So if I do person, or actually people dot and then stream dot, and look at those methods, right? So min, peak, reduce, sorted, take, while, so right here, drop, while, non-match you've seen, find first, map, and map to int. So basically, once you learn all of this, the way you write Java code will change, and you will become a much better Java developer. So this is all for this video. Next, let me also show you that you can use all of the goodness of Java functional interfaces with optionals, because again, optionals changes the way that you deal with null pointer exceptions in Java. Join me in the next one. See ya. Alright, let me go ahead and show you how to use Java optionals with functional interfaces. So if you've never heard about Java optionals, or if you've never used Java optionals, go ahead and check my YouTube channel where I've got this crash course on Java optionals. And I highly suggest you to learn how to use optionals, because they will help you a lot in terms of dealing with null pointer exceptions. So let me go back to IntelliJ and let me create a new package. So right here, optionals, and inside, let's go ahead and create a main class, and right here, public static void main, and there we go. So now let's go ahead and simply say optional dot and then of nullable. So right here, let's simply say null, right? And if I now press dot, check this out. You can see that right here you have a bunch of methods. But if you look closely again, so these methods, they do take, for example, the first one, or else throw, takes a supplier, right? So this supplies an exception. You can see or else, or, so right here, this takes a supplier. Map, again, function, if present, consumer, filter, and flat map. So right here, if present or else, right, is present or else get. So this is a supplier. So let me actually use this one, or else get, and then remember suppliers. So right here, oops, there we go. So let me simply say default value, just like that. Extract this to a variable, and let me simply name this as value. Now, if I go ahead and simply say south on value, there we go. If I run this, you can see that we get default value. But now check this out. If I simply add a value here, so hello, run this again, you can see that we get hello, right? So let's try something else. So instead of or else get, let's go ahead and simply say dot or. So right here, so or else throw. So this again, we have to supply an exception. Oops, just like that. New illegal state exception. And you can have, for example, a message right there. Exception, for example, right? So you can see that if I extract this to a variable, this is a supplier, and we've learned about suppliers, remember? So right here, so this is a supplier, right? It takes no arguments, but it supplies a value. So there we go. Now let me again show you something else. So if I delete this, so instead of saying or else throw, let's go ahead and use, for example, so let's use something that has a consumer. So if present, there we go. If present, we receive the actual value here, and then we do something with the value. So right here, let me simply remove that, and let me move this above, indent this. There we go. Now, because I only have one single value, but basically you could do like some logic right here, right? If you had like, you know, something that you wanted to do, like a business logic, right? So now, because I only have one value, I can delete all of this. I can delete that, and I can even go one step further, use Lambda method reference, just like that. And look at this, it looks beautiful. So now let me go ahead and simply say john@gmail.com. And in fact, let's go ahead and pretty much have a custom message. So right here, so email, and what we're going to do is simply say south, and then sending email to, and then email. There we go. Now if I run this, you can see that right here we do get sending email to John. But now as soon as I pass a null here, right, if I run this, we get nothing. But now I can go ahead and pretty much change this with, so there is another method right here. So if present or else takes a consumer, and then the other empty action is a runnable. So that is our consumer. So let me actually grab this so you can see what am I doing. So this is the first one, so this email, and then right here we have to pass comma right, comma, and then a runnable. So a runnable goes like that, and there we go. So let me pretty much just put this on a new line and this on a new line, just like that. And then if I close that, indent things, there we go. And then here, what I'm going to do is simply say south cannot send email. There we go. Now, if I run this, you see that we have cannot send email as a default value. So again, I can remove that and have method reference, and look at how this now starts to flow, guys. So this is the power of functional programming, streams, optionals, and once you start writing code like this, you can achieve a lot more instead of using imperative approach. So as I said, go ahead and enroll to this course right here, where I teach everything you need to know about Java Streams API. Also, if you want to learn about optionals, go ahead and check this video where I show you how to use optionals and how to be safe with no values. This is all for this section. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's go ahead and learn about this awesome design pattern called Combinator. So let me go ahead and first create a new package. And right here, I'm going to simply name this as Combinator and then pattern. So right here, what I want to do is to create a class. So I want to create a class, and let's say that we will start with a user. So a user, or actually a customer. So we have a customer, and this customer has few properties. So let me collapse this. So private final string name. Let's also give it an email, phone number, and let's also give it a local date for date of birth. Now let me go ahead and pretty much just add those to a constructor, and let me generate some getters right here. So getters, just like that. So now let's say that you have a system, right, where customers do register to your system, and you need to perform some kind of validation, right? So what you would do, for example, would be something like this. So inside of your package, you would create a class, and then customer validator, and then service, right? And in this class right here, you would have few methods to validate few properties of a customer, right? So you could have a method. So right here, you could say public, and then Boolean is email valid, right? And this takes a customer, or better, takes a string email, right? And right here, you'd simply say return, and then email dot contains, this is a rubbish validation, but this is just for illustration purposes, right? So contains that, or actually contains the @ symbol. For now, let's keep it simple. Then you might want to have other validation for the actual phone number. So right here, so is, and then phone number valid. So this will be phone number, and then right here, phone number, right here contains. So instead of contains, let's go ahead and simply have a simple validation. So it starts with, and then plus, and then 0, right? And then what did we have? So if I go back, so we have date of birth. So let's go ahead and simply say that the date of birth, so right here, is adult. So is adult. So right here, we take a local date, and then DOB. And then what we're going to do here is simply say period, dot, and then between. So we're going to calculate the number of years between two dates. So the start date will be inclusive, so this will be the DOB, so customer's date of birth, and then local date dot, and then now, and then right here dot, and then get years. And let's say that for someone to be an adult, they have to be over 16, just like that, right? So if I put this full screen so you can see, so this is then your customer validator service, right? So now the way that you would use it is, let's go ahead and create a new class. So main, and then public static void main, like that, customer, and then customer equals to new, and then customer, and then right here, let's go ahead and simply say that this is Alice, and then she has an email of alice@gmail.com, and then the actual phone number is plus, and then 0, so oops, plus and then 0, and then any random number. And finally, let's go ahead and simply say that she was born, so local date of, and then 2000, just like that, and then 1, and then 1, and there we go. So if I collapse this, and you can see that now we have a customer that we can perform some validation. Now obviously you know, this validator service, right? So this could even be private, so private, and then private, and then right here, so let's go ahead and combine the both. Let's go ahead and combine everything. So is actually let's go ahead and simply say public. So this is the actual interface that we provide to clients, so public, and then boolean, and then is valid, just like that. And this now will take a customer, and now what we're going to do is simply say return, and then is email valid, customer dot get email, and then and then is phone number valid, customer dot get phone number, and finally and is, and then adult, customer dot, and then get, and then DOB, just like that. So this is actually, you know, normal code, but so what I want to teach you really is how you're going to be able to use functions to change this in a much better way and a neat way, right? So here, if you have extra validation, you have to have another method like that, and then simply append here, and then basically right here you don't have visibility whether you know, whether the phone number was invalid or it wasn't an adult or anything, right? Because this simply returns a boolean, right? Is valid. So if I go ahead and show you what I mean, so right here, let's go ahead and simply say customer validator service equals to, well, actually let me rename this to validator service new, and then customer validator service. Now let's go ahead and simply say validator service dot is valid, and then pass customer. There we go. So what I'm going to do actually is inline this. Oops, not that. So basically I want to inline this guy right here, so like that, and then I'm going to do a south, just like that, and then end that like that. So now if I go ahead and run this, there we go. So you can see that this customer is valid, and from now on, let's say that we can store customer in, and then DB, right? So now actually let me say if, and then valid, right? So now if I go ahead and pretty much just, for example, remove the @ sign, run this, you can see that now it's false, so it's not valid. And also let me go ahead and remove the plus sign right here. There we go. Still not valid. But now you don't know exactly, what is wrong with our validation. So the combinator pattern, it's an awesome design pattern that allows you to chain functions together. So basically a combinator is a function that might take other functions as arguments and returns new functions. So this is an awesome pattern that I'm pretty sure that you will love. And that's what I'm going to teach you next. All right, let's go ahead and use the combinator pattern to improve this validation service right here that we have. So validator service actually. So this validation so this class right here is okay, but we can do way better than this, right? Because right here, for example, if you want to have a different method that validates, for example, just email and the phone number, then you would duplicate this, so right here, and then you would say is valid phone number and email, and basically just remove, for example, is adult from here, and we don't want to do this, right? So we want to have a very beautiful interface that we can simply chain all of these validations together. So let's go ahead first and expand the project tab, and right here let's go ahead and simply create a class, and this will be called customer, and then let's actually name this as registration validator. There we go. And instead of a class, let's change it to an interface. Now what I'm going to do here is the following. So right here I'm going to say that this will extend a function. So remember, we've used functions right here, and the first argument that we want for this interface is a customer. So the type of it is a customer, and then right here let's go ahead and simply say validation and then result. So let me end that just like that, and let me put this on a new line so you can see exactly what we're doing. Now this validation result, this will be an enum, so enum, and then validation, or let me actually just copy and paste this. So validation result, just like that, and now I can import this. Oops, actually I did the right thing, and let me actually do a static import right here. There we go. Now here what I'm going to do is have few results that I want my validator service, or actually my customer registration validator to have. So one, I want this to be success, right? So this is where all the validation is successful. Then we have few errors. So right here we have phone number not and then valid. We also have email not and then valid, and we also have is not an adult, just like that. So the way that we're going to use this with this interface is as follows. So this is where combinator pattern kicks off. So right here we're simply going to have the validations that we want, right? So here you can have as many validations as you want, and then you chain them together at the end. So right here let's go ahead and simply say static, and then right here what we're going to return is this guy right here. So the same interface. So right here we will return this function right here, right, that takes a customer and returns a validation result. So right here I'm going to say is and then email valid, and then I'm not taking anything there, but right here what I want to say is return and then customer, and right here I'm going to say customer. So basically the exact same validation that we had before. So customer dot and then contains and then at. So if this is the case, what I'm going to do is simply return, you guessed it, success. Otherwise phone number or actually not phone number, email is not valid. And let me have a static import for this, and the same for success. There we go. Now let's go ahead and do the same for phone number. Right here, let me actually steal some code. So from here, what did we have? We had this. So I'm going to copy that, go back, and then is phone number valid? And then I'm going to change that with this, and then customer dot get phone number starts with that. So if that is the case, then it's valid. Otherwise, so right here, phone number is not valid. So let's go ahead and do the same for is adult. So right here, static, and then customer registration validator is an adult. There we go. Let me steal some code from here. So this is what I want. Just like that. Go back, and then customer, or actually return customer, and then I'm going to paste that, and then right here, customer dot, and then get DOB. So if this is the case, right? So if the customer age is bigger than 16, what I'm going to do, so let me put this on a new line. So if it's bigger than 16, what I'm going to do is simply return success. Otherwise is not an adult. There we go. Indent this properly, and there we go. So one final thing that now we have to do is right here we have all of these functions, so these three functions, and the combinator pattern allows us to chain all of these functions together. So the same way that you saw with a function where we can use and then, and the same with predicates by using I think it was and, right, or we can have the same logic with the combinator pattern. So right here, what I'm going to do here is the following. So I'm going to have a default method, and right here I'm going to return a customer valid data, so the same thing that we did here, and then I'm going to say and, right? So right here we're going to take a customer valid data, and then I'm going to call other. So basically this is where the magic happens, right? So I'm going to say other, and inside I'm going to return, and then customer, and then inside what I'm going to do is simply say this dot and then apply. So we are going to apply this customer, and I'm going to extract this to a variable. So I'm going to say result, and now check this out. I'm going to say return, and then result dot equals, and then success. So if it is equal to success, I'm going to apply the other validator dot and then apply, and then customer. Otherwise, I'm going to simply pass the actual result, not super result. There we go. So if we get to this point, we know that we have an error. So now this is complaining because I need to pass semicolon right here. So let's go ahead now and use this awesome interface. So let's go back to the main method right here. And now let me simply comment this out, and let me simply add an @ sign right here. Or actually, let me simply leave it as it is. And then I'm going to show you exactly all the errors. So now let's go ahead and simply say customer, or actually not here. So using combinator pattern. So right here, let's go ahead and simply say customer registration validator, and then dot, and check this out. So we have all of these methods, right? Is an adult, is email valid, and is phone number valid. So let me go ahead and simply start with is email valid, right? But now what I want to do is the following. So right here, I'm going to say dot, And then check this out. We have this method. So and right here. So this is the one that we defined. So I'm going to say and then let's use the rest. So if I do, if I press Control Shift, you can see that we have the other methods. So is phone number valid? Dot and then is an adult. There we go. So if I now add a static import, you can see that now this becomes much cleaner. So now we have these three methods that we have chained together. The way that we use it is simply by saying dot and then apply and then pass customer. There we go. Now if I extract this to a variable, so result, and let's go ahead and simply say south and then result. So now what I'm going to do here is say if and then result not equals to success. So success, we're going to throw. So let's throw. So throw new illegal state exception. You could have your own exception, but for now, let's go ahead and throw an illegal state exception and then the actual result. Dot and then name. There we go. And basically this will actually print out the same thing right here, but I want you to see the actual result. So let's go ahead and scroll up and let's start with a valid customer. So at Gmail, and then the phone number has to start with plus and then 0. So if I go ahead and run this, there we go. We have success right here. And if I scroll up, let's now check all the validation that we have. So let me remove the @ sign and then run. There we go. You see that email is not valid and we've thrown an exception, right? So email not valid. So if I add that back and if I remove a plus here, run this. There we go. Phone number not valid. And if I add a plus there, and let's make sure that this guy was born, 2015, or this guy, Alice was born 2015. So, which means that, she's not an adult. So if I run this, you can see that is not an adult, right? And you can even customize your exception that we throw by including the name or an ID or anything like that. But basically now you can see the power of the combinator pattern. So if you have more stuff that you need to chain to this validation, so let's say that the requirements change, you can simply duplicate this and then have your custom implementation inside of the interface that we've defined. So this one right here, so customer registration validator, and then just chain all the validation logic and scenarios that you have. And this is the power of the combinator pattern. So one last thing that I want to show you is that, so if I command Z a couple of times there, so basically, so right here, you see that we call dot apply. So if I comment this, and then right here, let me simply remove the apply there. So the cool thing about these functions, so let me change the variable right here to a validator. So the cool thing about this, right, is that this is lazy, right? None of this stuff is run until we invoke the dot apply. So if I say result right here, you can see that we have all of these methods, right? We can compose, apply, so on and so forth. But if I run this, you can see that nothing gets printed out. And even if I, for example, right here, so where we return here, so the email so right here, so is email valid? So let me grab that. And then let me simply south and then running email validation. And then right here, simply return that and end that with semicolon there. So even if I run this, you can see that we still get nothing. But as soon as I revert all of this, just like that, and then call apply, now check this out. If I run, you can see that we have the running email validation. And I think I need to undo all of this and then run it again. And there we go. So running email validation, right? And then we have is not an adult and the actual exception. So I hope that you see the power of the Combinator pattern. I use it whenever I can to perform validation like this, and you should also do it. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Alright, so in this final section, let me go ahead and explain you a few things that will help you to fully understand the functional interfaces and functional programming with Java. So go ahead and create a new package, and in this package we're going to call it as final and then section right here. So inside, create a main method, and then let me put this full screen like this, and then ps and then VM for public static void main. And right here, what I'm going to do is I'm going to write some JavaScript, and there we go. So what I want to touch on this video is callbacks. So maybe you've done some JavaScript, and JavaScript, they have this notion of callbacks. So a function in JavaScript looks like this. So this won't work in Java, but it looks like this. So you have a function, and then you give it a name, so hello, and then right here you might have, for example, a variable, so let's say, and then first name, last name, and then callback, something like that, right? So right here, what we're going to do is, let's say, for example, the last name is not provided, then we simply have like console.log. So let's simply say console.log, and then right here, first, and then name, and then I can say if we have last name, then we're going to console.log, and then last name. Otherwise, we will have this callback. So we're going to invoke the callback, right? So you might have seen code like this in JavaScript. Basically, this is an extra function. So if I take this, Command C, and then go to Chrome, and then inspect, and then right here, go to console, paste my function there, and then enter, you can see that we have undefined. Now, if I say hello, and then say, first name John, and then pass a null there, and then right here I can pass a function. So this is a callback, right? So console dot and then log, and then no last name provided, and then end this with parentheses here. If I now run this, oops, we have a error there, and they shouldn't have the column there. So enter, and you can see that now we have John and then no last name provided. So basically, you can see that this callback right here is a function, and you can have, like, you know, a lot of logic in it, right? But you know, this is very simple, so we're just logging. But if you want to have, for example, an extra logic that goes to the database and does, you know, some other stuff, you could definitely do it. I'm just showing you the callbacks in JavaScript. So right here, if I now pass, so right here, if I now say Alex and then Montana, and then run this, you can see that now we're not printing the actual callback, right? So now we have John and then Montana, the last name. So we can achieve the same in Java using functional programming and the functional interfaces. So the way we're going to do it is as follows. So let me simply comment this right here so you have it for reference. So now what I'm going to do is actually have a static and then void, And right here, what I'm going to do is actually combine both worlds. So we can have a regular method, so a normal Java method, and also inside as a parameter, we can have a function, right? So this is, programming, because now we are free to do whatever we want. So right here, you see static void, and then let's go ahead and simply say hello. And then right here, string, and then first, and then name, string, last, and then name. And then right here, what do you think we need, right? So remember, we've learned about functions, BiFunction, consumers, suppliers, predicates. So we kind of just want to have a function that might take, for example, last name. If it's there, print it. Otherwise, have, for example, a default message. So right here, what we're going to do is simply say consumer, and then of type, and then string. And then let's simply name this as callback, just like that. There we go. And then right here, let me simply say south, and then first name. And then I want to say if, and then last name equals to null, right? We could even say is blank, right? But equals to null. So if it's equal to null, or actually let's revert this. So it's the same as the function that we have right here as JavaScript. So if it's not equal to null, let's go ahead and simply say south and then a last name. Otherwise, else, we're going to say callback dot and then accept, and then the string that we want is first name, for example, right? So let's take this first name right here and then do something with it. So now the way we use it is as follows. So let's go ahead and simply say hello, and then John right here, and then Montana, and right here let's have our callback. So let's go ahead and simply pass null for now, right? So if I run this, there we go. You see that we have John Montana. But now let's go ahead and define this callback. So right here we'll have a callback that takes a value, and the value will be the actual first name. It doesn't matter. And then we will do something with it. So right here, south, and then what did we have? So right here we said last name not provided. So let's do the same here. And then for, and then plus, and then John, and then value, right? So you could even change this to first name if you want, but I'm just going to leave it as value. Now if I run this, you see that we have John Montana. But now watch this. If I pass null right here and then run, there we go. No last name provided for John. So basically I just want to show you that you can combine a normal function with these functional interfaces and do stuff like this and achieve a similar concept as JavaScript that they call callbacks. So there are other languages that have the similar concept, but JavaScript, you see a lot of these callbacks being thrown, and you can pretty much do the same with functions. Another way that you might see callback is right here. So because right here you might not want to pass a default value, right? So you might have something like this. So right here, let me just duplicate this and then call it 2. And then right here, so I'm gonna simply remove this and then runnable, and this will be the callback. And then right here, callback dot and then run, right? So this is a bit different now. So right here, the way we use it is simply say hello, like here, and then 2, and then right here, you simply pass this runnable right here, and you have no value there. Basically, this now is the exact same thing as this concept right here, right? Because we're not taking any value, and because I only have one line there, I can simply do this and then check this out just like that, and beautiful code. So now if I run this, you can see that it's the exact same thing, but right here, we're not taking any arguments. So there we go. So this is how you combine both worlds, where you can mix and match these functional interfaces with normal functions and have callbacks. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let me go ahead and teach you about Lambdas. So we've been using Lambdas throughout this course with, all these functions, but basically let me show you exactly how they're used. And for example, if you only have one return statement, if you have 2 arguments, what you should do when using Lambdas. So let's go ahead and expand this. So command and then 1. And right here for this main method, let me go ahead and simply name this as callbacks, just like that. Now let's go ahead and create a new class and then simply call it as Lambdas. There we go. Oops, not Lambdas, but lamb, and then des, just like that. Now let me collapse that, and then public static void main. Now inside, let's go ahead and have a function. There we go. That takes a string and returns a string. There we go. So let's simply say print and then name equals to. So this guy will take name, and then right here, so this part right here, it's a lambda, right? So this is a lambda where this is the actual argument, right? So this name right here is what comes from this data type. So right here, then you have to pretty much just do the following. So if you have only one line, so if you simply return immediately, you can simply do this. So south, and then, well, actually not even south, my bad. So you can simply, and this is not a good example, so not print name, but let's simply say upper and then case name, for example, something like this, right? So now right here, if you simply return immediately, you can simply do this. So name and then dot and then uppercase, right? So you can immediately do this. So this is only when you have one return statement right after this arrow right here. So because you only have one return statement, and you can even see that IntelliJ is telling you that you can use method reference. So this is because right here, this is the same as doing this, right? It's the exact same thing. So this is more understandable, but once you get too comfortable with this, you'll start to use code like this. Now, another thing is right here. So if you have to do some extra logic and not return immediately, you need to have these curly braces right here. So now you can have a logic, right? So you could, for example, say if and then name dot or actually is blank right here. So if it's blank, then you can throw new illegal and then argument exception, something like this, right? And then right here, otherwise, now because I need to return, I need to say return and then name to uppercase, but also I need to add semicolon right here, right? So you can see that now this is the actual method body for this lambda, right? So this lambda, so this is the entire thing right here. So another thing that you could do with lambdas is, you see right here where you have name. So if this is a BiFunction, so BiFunction, just like that, and then right here let's simply have let's have an integer right here, integer, and this will be age, right? So now you see that I need to put age right here because this data type is for this one and this data type is for the second one, right? and string is what this BiFunction returns. Now, because I have two arguments, I need to do this. Right? I need to enclose them within these parentheses. So let me actually go back for a second. So right here, so where we have a function. So you see, this is a function. I can even, enclose them with parentheses. But because I only have one argument, right, into this function right here, I can simply ditch this, right? But if you have a BiFunction, and right here, let's simply say integer again, and then age. Now you need to enclose like that, right? And you could, do something like another logic right here. So south, for example, and then age, something like that, right? And, the way you'd use it is as follows. So uppercase, name, dot, apply, and then Alex, let's have Alex here, and then Alex is 20, right? There we go. And this returns a string right here, upper cased name, and then south, and then uppercase name. And I can even inline this like so. If I run this, there we go. So 20 and then Alex. So basically this is this logic doesn't really make sense, but I just want to show you exactly different ways that you can use these lambdas right here. So if you have any questions on lambdas, go ahead and drop me a message. Otherwise, let's move on. All right, so just to let you know that I think I didn't mention this at the beginning of this course, but when you use these functional interfaces, you see right here where you define the actual inputs and outputs of functions, right? So string and then integer and then string. So these right here, they have to be the object type and not the primitive. So for example, integer, right? So you could have an integer like this. So integer and then number equals to null, right? And then you can also have integer and then let's say counter. And right here, I can't say this. So this is invalid, right? Because this is the primitive version of this object type right here, right? So right here, you either have to say a number. So it could be negative number or positive number. So if I do a 0 right here, you can see that this goes away. So for that reason, you are not allowed to have primitives in here, right? Because if you have to pass nulls, then you can. So with primitives, you cannot. So right here, you see that we have this integer right here. So I can go ahead and simply say null right here. And you see that works. But if I was to have this integer, so the primitive type, that does not work. And also, one thing that I've been doing a lot throughout this course is having static right here. So static. So the reason why I've been doing static is because I'm outside. So right here, I'm outside of the main function. And the main function is static, right? And you can only use static methods inside of this main function. So right here, you can see that this still works. But if I remove the static keyword, you can see that it does not work, right? So this is something that to bear in mind. Your functions and BiFunctions, they don't have to be static, right? In fact, having static throughout your code base is not practical. So ideally, what you would do is simply have, for example, so let's say that you have a class. Let me actually put this inside. So just like that. So let's say that you have a class and then call this as service, for example, right? What you should really be doing is like having, publics and then your function, for example, or predicate or consumers, right? So consumer of string and then blur equals 2 and then s, right? Just like that. And then basically this is your public interface. You can also change this to private or no access modifier at all. So this is package protected, right? So just to bear in mind that, you know, they don't have to be static and you should avoid static. But the reason why I've been using static is because I've been doing everything inside of this public static void main method. So there we go. If you have any questions on primitives and the use of static keywords, go ahead and drop me a message. Otherwise, catch me on the next one. All right, let me go ahead and quickly show you the rules that come with functional programming and everything that we've learned throughout this course. So the first thing that you should know is that there should be no state around your functions, right? So the functions, they have to be pure functions. So they shouldn't depend on any other state. So for example, if you have a global state, like or a global variable, your function should not depend on that global state, right? So that's the difference between pure and impure functions. So pure functions don't depend on global state. Impure functions do depend on global state. And that comes with the side effects, right? So your functions should have no side effects other than everything inside of the body of your function, right? It shouldn't have a side effect outside of the function. And also higher order functions. So a function is considered to be higher order function if one of these two conditions are met. The function takes one or more functions as parameters. So we saw how to pass functions inside a normal functions, right? Or if the function returns another function as result. So with the combinator pattern, that's exactly what we've done. So let me actually show you. So right here, so with callbacks, so right here, so right here, so you can see that right here we are passing a function right here. So this is a function, right? And also within our combinator pattern, so remember, so customer and then registration validator, check this out. So right here we are returning a function. So this interface extends customer, or actually extends function that takes a customer and sends a validation result. But if you check the return type of all of these methods right here, so if I do a command shift and then minus, you can see that they all return the function right here. So this means that we are satisfying with this property, higher order functions. So make sure that, for example, let me actually show you, the no state and pure functions and side effects. So if I go back to, let's say, lambdas right here. So you see this function right here. So int by function right here. So I should never depend on, for example, counter, right? So let's say that I do, for example, south and then counter. Or if I change the state of counter, right? I should never do this because it will break all of this, right? So you see that there might be some side effects on the outside of this function right here, right? So outside of this function, there might be some side effects. Also, you see that you are now mutating state, and it's no longer a pure function. It's an impure function because it depends on global state. So you never want to do this. Or for example, increment the number. So number, and then, increment, plus, something like that. You should never do it, right? So your functions, right here, they should be self-contained, right? So they should only depend on the state that you define inside. So right here, I could say int and then counter equals to 0. So this is absolutely fine, right? Because this counter, so this counter right here, it's only visible inside of this function and not the outside world. So if you have any questions on these properties, go ahead and drop me a message and I can give you more examples. But this is pretty much everything you need to know about functional interfaces and functional programming with Java. If you have any questions, go ahead and drop me a message. Next, let's go ahead and wrap up this course. Okie dokie, amigo. I want to congratulate you for completing this course and practicing throughout. So, as you saw, for you to write functional programming, you just have to shift the way that you think. You no longer think about regular Java functions, but you start to use functions, BiFunctions, predicates, consumers, suppliers, so on and so forth. Now, the next step for you is to enroll to my course on Java Streams API, because once you combine everything that you've learned in this course with Java Streams, you will start to write code that really shines. Instead of you writing code that takes, for example, 20 lines of code, you'll simply take 5 lines of code with streams and functional interfaces. So this is all for now. Go ahead and subscribe to my channel to get more videos like this, and it really means a lot to me to see a lot of you sending me messages suggesting for new courses, and I'm trying my best to give you awesome content that will allow you to become a software engineer. Also, if you haven't joined the private Facebook group, go ahead and join, because that way you can see what's up, you can connect with other students, and if you have any questions, just drop them and I'm pretty sure one of us will be able to help you. This is all for now, and I'll catch you on the next one. See ya.